Good day, grade 10 learners. Welcome to our mathematics lesson. I am Skolile Ngove, and this lesson is proudly brought to you by the Gauteng Department of Education. Thank you very much, grade 10, for joining us. We are going to continue learning mathematics, and in this lesson, we're going to learn about trigonometric graphs or trigonometric functions, and we're going to look at the effect of A and Q on the sine and the cosine graph. Let's be ready for our lesson, grade 10. Make sure that you have your book with you, you have your pencil, you have your ruler, you have your calculator. We are going to be sketching graphs even today, and we're going to look at the effect of these two parameters. Okay, let's be ready, grade 10. Let's be ready. I hope that now you are settled. Now let's continue. And then at the end of the lesson, you should be able to study the effect of A, parameter A, on the graphs defined by y is equal to A sine x and y is equal to A cos x, where our domain is from 0 to 360 degrees. Definitely at the end of this lesson, you will be understanding the effect of A. Okay? The other one, we're going to study the effect of Q on the graphs defined by y is equal to sine x plus q and y is equal to cos x plus q for this domain when x is from 0 to 360 degrees. Remember we said we're dealing with this domain from 0 to 360 degrees. Definitely at the end of this lesson, you will be understanding the effect of Q. Okay? Right. That's what we want to learn today. We've done these trigonometric functions, we've done trigonometric equations, we've done algebraic functions. There's a link between trigonometric functions and even algebraic functions. They are functions anyway. Okay? It's only that they are functions that we find in paper 2, but they are functions. Okay? Right. Now, I want us to do this just to remind ourselves about what we've been doing. Okay? On the given Cartesian plane, sketch the graph of f of x is equal to sine x and g of x is equal to cos x. Now, I'm going to give you 5 minutes because you have to draw the Cartesian plane and then draw the two graphs. Don't use the table values. By now, I want you to know where is cos 0. We're using these 5 points. 1, 2, 3, 4, 5. Cos 0, what is it? Cos 90, what is it? Cos 180, cos 270, cos 360. Just like the sine x. Sine 0, sine 90, sine 180, sine 270, sine 360. Just use these 5 points to sketch your graph. I'm going to give you 5 minutes. After 5 minutes, we're going to mark our work. Let's try. Welcome back, grade 10s. Welcome back. Let's mark our work now, okay? And you are making corrections and take note of this. Maybe let's say you missed the previous lessons. Please take note of this. Let's start with the sine graph. Sine x. The sine graph, where does it start? It starts at the origin. Sine 0 degrees is equal to 0. You can check that with your calculator. Sine 0 degrees is equal to 0. So let's plot our point there at 0. What happened to my point? Oh, it's there. Okay. Let me clear this ink. Okay. All right. And then sine 90 degrees. 1. Okay. Remember that. And then what about sine 180? What is sine 180? 0. You must know these critical points. You must know them. Okay. And then sine 270 degrees is -1. Please correct that if you got it wrong. And then sine 360 degrees is 0. Okay. And then this is our sine graph. It looks like this. That's the sine graph. Please correct it. What about the cosine graph? Where does it start? It starts at 1 because cos 0 is 1. Cos 0 is 1. We plot that. What about cos 90? Cos 90 is 0. Please don't forget that. These are the critical points that we need to know so that we can sketch our graphs. And then cos 180 is -1. Then cos 270 is 0. Then cos 360 is 1. Okay. And then we join these points. We have our sine graph. You can look at these two graphs. What is the difference between a cosine graph and a sine graph? Okay. Right. Now let's move on to the next part. Remember, today we're learning what? The effect of A and the effect of Q. Okay. Right. I've sketched the graphs because you cannot continue sketching the graphs the whole lesson. So the graphs are already there. I want us to use this term. For f of x is equal to sine x. Let's call it the parent graph. It's like the other graphs are coming from this parent graph. Some people call it the mother graph to show that it's the original graph and then these other graphs are coming from it. So f of x is equal to sine x, the parent graph. Now, what has happened to A here? We have C. For g of x, A is equal to what? It is equal to 2. And then for h of x, A is equal to 3. Okay? We want to see the effect of this A on the graph. Maybe some of you can already see the differences there, or the effect of this parameter A. Let's use our table. Okay? You can be writing notes. I'm going to give you time to do an activity after that. Right, let's compare f of x, the parent graph, the blue graph, with g of x, which is the black graph. Now, what is the amplitude? What is the amplitude of g of x? We know sine x, the amplitude is 1. We did this in the previous lessons. Let's look at g of x. What is the amplitude? How do we find the amplitude? We say y maximum minus y minimum divided by 2. So A for amplitude, it will be 2 minus -2 divided by 2, which is equal to 4 divided by 2, which is equal to 2. The amplitude is 2 for g of x. What is the value of A for g of x? It is 2. Now, I want you to compare the amplitude and the value of A. What can you say? Amplitude and the value of A. What can you say? Do you see that A is actually the amplitude? A is the amplitude. Okay? They're given a graph, they say f of x is equal to A sine x. And then they say find the value of A. Know that A is the amplitude. Okay? A is the amplitude. Right. And then let's move on to the next part of our lesson. Right, again, I'm going to give you a table. We're going to compare these critical values using what? Or critical features using what? The tables. Now, let's look at the maximum. We have the maximum for f of x which is 1, y is equal to 1, minimum, y is equal to -1. This is the maximum for f of x. This is the minimum for f of x, -1 there. But what is the maximum point for g of x? You see, that's 2. So it is at y is equal to 2. What is the minimum point for g of x? It is at y is equal to -2. So what is the value of a for g of x? I'll give you time to compare f of x and h of x, okay? I'll do g of x and f of x, then you will do f of x and h of x. Right, now a is equal to 2. Do you see that? So we can generalize and say the maximum value is going to be y is equal to a, and then the minimum value is equal to y is equal to, what am I saying? It should be y is equal to, y is equal to -a. Please take note, we're looking at the graph of this form. We haven't talked about the graph that have been shifted upwards or downwards yet. We're looking at the graph of this form. Please take note of that. Okay? Right. Please write your short notes as we move on. Let's move on to the next part. Remember WhatsApp line grade 10s. If there are any questions, please don't hesitate. 063 508 1301. Let's engage each other during the lesson. Okay? Right, and then we have this table. The period, we talked about the period of the graph in the previous lesson. For f of x is equal to sine x, the period is 360 degrees. Let's look at the black graph, the g of x graph. It will repeat itself after how many degrees? It is still 360 degrees. If you check, you can check that. Okay, what about the range? The range is from y is equal to -2, -2 included, up to y is equal to 2 included there. So we can say the range of y greater than or equal to -2, and then our y less than or equal to 2. Or you can say y element of -2 included to 2 included. You can write it like that. That's the range. Okay? Now, what's the value of a for g of x? A is equal to 2. Do you see that? There's a link between the range and the value of a. So we can generalize and say the range is going to be y greater than or equal to -a, but less than or equal to a. Or you can write it like this: y element of -a included to a included, like that. See that? What about the period? Does a affect the period of the graph? It doesn't affect the period of the graph. A does not affect the period, does not affect the domain. A affects the things that involve the y values. If you check the range, you're looking at the y values. The maximum, we're looking at the y values. You see that? Okay, that's what A affects. But the domain, the x values, are not affected. Check again. The x coordinate of all the three graphs there, they're at 0, 180, the x coordinates of the x-intercepts, and then 360. Do you see that? They are not affected. But look at the y's. The y there is there, the y there is there, the y there is there. The y there is here, y is there, y is there. So A affects the y values. A affects the y values, not the x values. Okay? Right. Now I'll be giving you time to do an activity now. Let's go to the next one. All right, I want you to compare f of x and h of x. Please fill in the table. I'm going to give you 2 minutes. What's the amplitude of h of x? 2 minutes. Welcome back, Cretans. Did you manage to find the amplitude of h of x? What is the maximum for h of x? 3. The minimum, -3. So the amplitude is 3 minus -3 divided by 2. What is 3 minus -3? That is 3 plus 3. 3 plus 3 is 6. 6 divided by 2 is 3. So the amplitude is 3. Okay, 3. What is the value of a for h of x? Is 3. It's confirming what we said. We said a is actually the amplitude. Do you see that? A is actually the amplitude. So don't forget that. Let's move on to the next one. Again, I'm going to give you some time, but for this one, I'll give you 1 minute. Right? 1 minute. Fill in the table. We are comparing f of x and h of x. What is the maximum for h of x? What is the minimum for h of x? Let's do that. 1 minute. Right, welcome back, Cretans. Now, what did you get? The maximum for h of x is y is equal to 3. The minimum for h of x is y is equal to -3. And then for h of x, the a value is 3. Do you see that? We say the maximum for this graph, the graph of this form, would be y is equal to a, or y. The minimum is going to be y is equal to -a. See that? Okay? Right. I think you have that. Please try to write notes as we discuss. If there are any questions, remember, send us a chat 063-508-1301. Please try to send your questions during the lesson. Okay? During the lesson. We see sometimes we see your questions after the lesson. We try to answer them, but during the lesson it will be better. Right, and then let's move on to the next one. Right, this one I'm going to give you 2 minutes. 2 minutes. Let's try to fill in the table here. One, the period for h of x. One, the range for h of x. And then the value of a is 3. Let me just write the value of a for you there. The period for h of x and the range for h of x. 2 minutes. Right, welcome back, Return. Let's see, the period, does it change? We say that, we said the 8 does not affect the period, so it's still 360 degrees. What about the range? What about the range? Y values from -3 up to 3. So you can say y is greater than or equal to -3, but less than or equal to 3. So, or you can write it like this: y is an element of -3 included. Remember, square bracket means included. Round bracket means not included. That is excluded. Okay, right? And then 3 included there. Okay, right. Now, still on the effect of A. Very soon we're going to be moving to the effect of Q, but still on the effect of A, I want us to observe something. Right. Let's say this A becomes negative. What will happen? If A is negative, let's say we have g of x is equal to 2 sine x, and then we have another function now which is negative g of x, meaning -2 sine x. What will happen? I want to see that, okay? I want you to try to sketch that graph. Let me explain this. H of x is equal to 3 sine x, okay? And then t of x is equal to negative h of x. Remember, this is h of x. So you are saying it means that t of x is actually negative. H of x means -3 sine x. Okay, right. Now, if t of x is equal to negative h of x, a reflection, you're supposed to observe this on your own, a reflection of h about the x-axis. I want you to sketch the graph of t. Maybe just to confirm this statement, let's sketch the graph of t. Okay, let's sketch the graph of t. You can do that by reflecting or by just doing this. Let's do this. Maybe this one will be easy. Right, what is -3 sine 0 degrees, and then -3 sine 90? Kindly use your calculator for that. Then -3 sine 180 degrees, and then -3 sine 270 degrees, and then -3 sine 360 degrees. Let's use these points. 1, 2, 3, 4, 5. Right, you can use your calculator to find those points, and then you sketch your graph. Okay, let's have how many minutes? 4 minutes. I think 4 minutes will be fine. 4 minutes. Welcome back, grade 10s. Welcome back. Let's do this, but before we do this, let me thank Tissetong Secondary School. Thank you very much for your question. It is a very, very good question. Let me explain this part, and then soon after that, I will explain your question. It's a very, very good question. Please, everyone, you have to listen to the question and also how I'm going to explain that. If someone asks a question, it is not for that particular person. It assists all of us to understand things better. Thank you very much for that question. It's very, very good. I'll explain it after that. After this, sorry. Right, and then 3 sine 0, you should have managed to get 0 there. It should be 0. And then negative 3 sine 90 should be negative 3. Then negative 3 sine 180 should be 180, so it should be 0 there. And then negative 3 sine 270, it is, should be, am I right? Should be, yeah, 3, yes. And then negative 3 sine 360 should be 0. And then your graph should be like this. But I'll show you a nice one. Okay, let me just have my rough sketch here. That is t of x, okay? But here is the nice one. You see that? So t of x should be like this. Okay? Right. And then what do you observe? Does it confirm this? Yes, it confirms that. We are saying that multiplying the graph by a negative value reflects the graph about the x-axis for all functions, even algebraic ones. If f of x becomes, they are not equal, becomes negative f of x, it means negative f of x is a reflection of f of x about the x-axis. Okay, right. Now let me explain Sesong's question. It's a very good question. What does the question say? The question was like, say if it says x in an element of 0 degrees to 270, does that affect the period? What do you think? Can you try to answer that one? Does it affect the period? What is this anyway? This is the domain. Remember, these graphs, they start from negative infinity to infinity. And we can't draw graphs from negative infinity to infinity. So what do? We have to restrict the domain. So from 0 to 270, it means we're drawing our graph. Let's say these are the two graphs that we're drawing from here up to there. It means this graph will just appear. This part, you won't be seeing this part. You won't be seeing this part. You'll be seeing this graph up to there. The period is still the same. It's only that we have restricted the domain. If you check sometimes, they don't give you the whole domain from 0 to 360. They can restrict the domain from 0 to 90. You have to know that at 90, this graph starts at 0. At 90, it is at 1. Once you have this part like that, you have to know that this graph, its period is going to be what? 360 degrees. So the domain can be restricted anyhow, but that does not affect the period. The period is affected by something else. We're going to look at the other parameter. If you say put a coefficient, let's say sine 2x here, that's what is going to affect the period. But we're not doing that now. Okay? We're looking at the effect of A and the effect of Q for now. Okay? So the period is not affected by this. It's only that the domain is restricted from 0 to 270. I hope that I managed to answer your question. Please, if you are not answered, let us know. We'll try to explain again if it means re-explaining. Okay? Thank you very much for that. Now, from here, I'm going to explain the effect of A on the cosine graph because basically it's just the same thing like the effect of A. So let's quickly move through this. Even if you can sit and listen, still okay. Writing notes, we did that with the sine graph. I just want to, it's just confirming. It's just confirming. So it's going to be fast, and then after that we can move on to the effect of Q. Right. The graph The following diagram shows the graph of f of x is equal to cos x. On the same set of axes, sketch a graph of 2 cos x and h of x 3 cos x. So we know the effect of a, so it means 2 cos x is going to be, you are going to have 2 there as the maximum, negative 2 as the minimum, and 2 as the maximum there. And then the x-intercepts are not affected by a. That's what we said. The x-intercepts are not affected by a. And then we just sketch our graph, that is for 2 cos x. 3 cos x, the maximum is 3, the minimum is negative 3, the maximum there is 3. The x-intercepts again are not affected, they are still there. So the graph will be like this. You see that once you know the key points of a function, it becomes very easy for you to sketch. Remember, just sketching. Okay, you see that? That's what you're supposed to do there. Okay, I said you can listen for this part of the lesson, and then when we get to the effect of Q, we'll start writing. Right, what do we have here? Right, we have the graph of h of x equal to 3 cos x. From this, I'm not going to even look at the graphs. From the value of a, I can say that the amplitude is 3, since the value of a is 3. You see that? If you want to check the graph, you can see that 3 minus negative 3, that is 6. 6 divided by 2 is 3. But you can read your amplitude from the equation. Okay? And then a is 3 there, so the maximum should be y is equal to 3, the minimum should be y is equal to negative 3. By just looking at the function like that, I can find the minimum and maximum. Okay? Right? Please listen so that we can move fast. And then the period does not change, a does not affect the period, but the range. A is 3, so it means y is greater than or equal to negative 3, but less than or equal to 3. Just from that a value there. Okay? See that? It's faster. You find that these questions just 1 mark, 2 marks. You see? Okay? You should be able to interpret from the equation or from the graph. Right? Same here. Our a is 2, so the amplitude is 2, since the value of a is 2. Right, the maximum, so y is equal to 2, minimum y is equal to negative 2, since the value of a is 2. You see that? I hope you are listening. Please don't write, because if you start writing, you will complain about time. Right, and then the period is not affected. And then the range, a is 2, so y is greater than or equal to negative 2, but less than or equal to 2, since the a value is 2. Okay, so that is the effect of A. That's the effect of A. We're done with the effect of A. Now, what about Q? The effect of Q. Okay, I want you to try this, and then after that, we'll just discuss, and then we move towards concluding our lesson. Right, the first one I want you to do, we're going to compare f of x, which is our parent graph, and g of x, which is sine x plus 2. For f of x, it's like this is like plus 0. So that's why I'm saying q here is 0. Now, what is the amplitude of g of x, the black graph? What is the value of q for g of x? Can you try to fill in this part and this part in 2 minutes? Right, welcome back. What is the amplitude of g of x? There's this common mistake where when you're asked to find the amplitude, let me use f of x, and then someone reads the maximum point and say the amplitude of f of x is 1. That is very, very dangerous. Because now, what is the maximum here for g of x? It will be 3. And then someone just reads and say the amplitude is 3. That is very dangerous. So when you're finding the amplitude, what do? You use the formula. We say the amplitude is y maximum minus y minimum divided by 2. That's why we will always emphasize that when you're finding the amplitude, use the formula. Because it's just reading from the graph is very, very dangerous. If the graph is shifted upwards or downwards, it may be difficult for you to read from the graph. Unless the graph is not shifted, the middle point is on the x-axis, then you can easily read. But once it's shifted, it may give you problems. So the maximum value there for g of x is 3 minus the minimum value, which is 1. This is 1, you see, that's 1 divided by 2. And then 3 minus 1 is 2. 2 divided by 2 is 1. So the amplitude for g of x is 1. My question is, does parameter q affect the amplitude? Q does not affect the amplitude. Okay, q does not affect the amplitude. So the value of q here is, what is it? It's 2, né? It's 2. So the amplitude is not affected by q. Let me not comment on the maximum and range because you're going there now. Let's go to the maximum and minimum. Is q going to affect the maximum and minimum? Let's try to find out. Right, can you try to fill in this table? Let me give you 1 minute. You're not doing any calculation here, it's just reading from the graphs. So the maximum for g of x, the black graph, and the minimum for g of x, the black graph. And then our value of q is 2 from the graph here. Okay, right, 1 minute. Right, welcome back to the 10th. Now, what is the maximum for g of x? It is 3. What is the minimum for g of x? It is at 1. Y is equal to 3, y is equal to 1. Sorry, I'm writing too many ones now. Right, it's fine. Okay, right, now let's look at the maximum value of our original parent graph and the minimum value of the parent graph. What has happened to them to get the maximum for our new graph g of x and the minimum to get our new graph for our new graph g of x? Do you see that we've just said 1 plus 2? We've added the q value to get 3. And then you say negative 1 plus 2, and then we get 1. So the y values are increased by q units. If q is 2, the y values are increased by 2. Again, q does not affect the x values. Check here. The y-intercept is at 0, 2. Here it is 0, 0. Do you see that the x coordinates are not changed? It's still 0. Even here, we have, what do we have? 91. And then here we have 90 degrees, 3. Do you see the x coordinates are not changed? It's still 90 degrees, 90 degrees. Here, 180 degrees, 0. Here, 180 degrees, 2. It is only the y values that are changed. So what does Q do? If you add Q, the graph goes up by 2 units. What did I say? They say you add Q. If you add 2, the graph goes up by 2 units. So if you add Q, the graph will go up by Q units. That's the vertical shift. Okay, right. Now what else? Did I leave out anything? Now let's look at the range. Is the range affected by the value of Q? Is the period affected by the value of Q? Let's find out. Can you try to fill in this table? Let me give you 2 minutes. 2 minutes, yes. Let's try to fill in this table there and there for g of x. Once we do g of x, we'll just go through the h of x1 because it is just the same thing, right? And then try to do this in 2 minutes. Welcome back, grade 10. Now, does the period change because of change in the value of Q? No, it doesn't change. What about the range? Now the range is from 1, 2, 3. So meaning that, let me use this format. Y is greater than or equal to 1, and then but less than or equal to 3. Do you see that the range changes? So the Q value will change, the maximum value, the minimum value, the range. The amplitude is not changed. The period is not changed. Right. So what have we done to this value? We added Q. Negative 1 plus 2 is 1. That's why I'm getting this 1. And then 1 plus 2, we get 3. That's why I'm getting that 3. So the graph basically is shifted upwards by Q units. That's the effect of Q. Vertical shift. Okay? Right, now let's just quickly go through the comparison between f of x and h of x. Right? And then h of x, Q is negative 1. Does the amplitude change? No, the amplitude is not changed because our A here is 1 and our A there is 1. So the A value did not change. So the amplitude is not changing, still 1. and then the value of Q there is -1. So do you see that the value of Q does not affect the amplitude? We're talking about this red graph here. And then the maximum and minimum. Since this is -1, we're going to say every Y value is going to shift downwards by 1 unit. We're going to subtract 1. So what is 1 minus 1 is 0. Let's check. Yes, the maximum is at 0. And then here, let's say -1 minus 1 get -2. Is the minimum at -2? Yes, it is at -2. Do you see that? Okay. And then our value of Q here is -1. Right? The range, here you can just listen. Remember, just like we did with the sine graph, just listen. And then the range, the period is not affected. See that? And then the range, here we have -1. What would be -1 minus -1? That would be -2. And then Y is greater than or equal to -2. Yes, that's the range there, from -2 to 1. And then we say to 0, sorry. And then we say 1 minus 1, we get 0. You see that? So it's between from the minimum to the maximum. That's the range. And then that's our value of Q there. Okay. So this is the effect of, we have learned about the effect of A and Q. Please don't forget the effects of these two parameters, A and Q. Right. The following diagram shows the graph of f of x. It's just f of x. I don't know where these ones are coming from. Right, and then on the same set of x's, sketch the graph of g of x is equal to cos x minus 2, and then h of x is equal to 2 cos x plus 1. Let me start with g of x. So I left with about 4 minutes. I was going to give you time to do this, but if you can be ahead of me, try to do so. Okay, let me explain this. Let's start with g of x from f of x. So cos x minus 2. What is the meaning of that? Our q is -2. It means every y point of f of x must go down by 2 units. Right? So it means this point must go down by 2 units. So it should be here. This point must go down by 2 units. So it should be here. This point must go down by 2 units. So it should be here. This point must go down by 2 units. It should be here. And then this point must go down by 2 units. It should be here. That is for g of x. Then we can sketch our graph. I think it will be easy for me to draw from left or from right to left. Then, okay, and then I try. Let me try from this side. Almost. But this one looks almost, yes. So that is g of x. You see that? It becomes very easy if you look at, you understand the effects of these parameters. And then this one, if I just want to sketch from what I know, I may start by this. I'll use dotted lines for this one. I will start with 2 cos x. Now what is affected here? It is the amplitude, the maximum value, and the minimum value. Right, the 2 cos x part only, I'll use dotted lines. But the x coordinates, remember, are not what? Changed. So it will be 2, 90, then -2, then 270, and 2. Let me use dotted lines. Because we're not drawing 2 cos x, we're drawing 2 cos x plus 1. So that's why I'm using dotted lines. And then now, plus 1. Now I shift my dotted graph by 1 unit upwards because of that plus 1. So it becomes plus 1, plus 1, plus 1, plus 1, plus 1. Then we have our h of x. Okay, that is h of x. You see that? We've managed to sketch our graph by just understanding the effects of A and Q. Okay? Right, let me give you 1 minute to copy the homework, and then after 1 minute, we are going to summarize our lesson. Welcome back, returns. I really hope you managed to copy the homework. Please do it and make sure that you ask someone to check for you, or ma'am or sir they can check for you. Right, now let's summarize our lesson. We say that A changes the amplitude of the graph. It affects the amplitude, affects the range. What else? Maximum and minimum values. And then multiplying the graph by a negative value reflects the graph about the x-axis. If A becomes negative, if A is less than 0, then the graph is reflected about the x-axis. If Q is added, the graph shifts upwards by Q units. And then if Q is subtracted, the graph shifts downwards by Q units. We have learned about the effect of A and Q. Great turns. We are going to meet next week. Please don't miss the lesson. Next week, we're going to look at the effect of A and Q on the tangent graph. It's a very, very important lesson. Please don't miss it up. And then we have, someone asked about 2D trick. 2D trick is going to be done on the 7th of September. Please make sure that you join us 9 a.m. and then we're going to be dealing with 2D trick on the 7th. But next week, we're going to be dealing with the effect of A and Q on the tangent graph. Let's meet next week, returns. Enjoy the rest of your day.